Hello everybody, hello world, hello Philippines. This is again I am a singer, eternal voice. Welcome to my YT world. Okay, if you are not subscribing yet, just click the subscription button on this vlog video or live stream. Okay, actually this is vlogging. Okay, this is showing to you and discussing the different examples, problems related to science basic formulas, right? I discussed that last 2 days ago and then yesterday. Then there are about 30 plus minimum, but it's beyond that because there's a lot of science formulas. I'm just tackling all the basic formulas, right? So we've done already the forces, the gravity, the density, the weight, the mass. Now we're going to solve some problems on work and energy. Okay, something like that. So problem number 5. A cyclist travels from the inclined cliff road to the ground at 5 degrees for a total distance of 500 meters. The mass of a cyclist and the person is 90 kilograms and the friction force acted on the road is 16 Newton. What is the velocity of the cyclist at the bottom of the inclined road at the ground surface? A. 12.7 meter per second, B. 11.2 meter per second, C. 9.81 meter per second, D. 13.8 meter per second, E. None of the above. Okay, so how can we analyze this problem? So this talks about velocity and then the inclined road. So let's take into account the changes in potential energy, kinetic energy, and the wasted energy due to friction acted on the inclined road, something like that. Okay, so I must illustrate this first. So this is like this. Okay, so let's say this is the cyclist here. Okay, so we have velocity initial and velocity final here. Okay, this one, velocity initial of the cyclist here and the velocity final here. Okay, so we have the mass of the cyclist and the and the bicycle, of course. How much is that? 90 kilogram. Okay, 90 kilogram. So like this, and we have this ground, and this is the cliff, and this is 5 degrees, and this is the height, like this. So this is the cliff road, the cyclist going downward. So this is the end where he takes the final velocity. Okay, then the angle is 5 degrees, and we have the ground and we have the cliff, like that. Okay, so in this we need to use the conservation of energy. Okay, so we need to sum up all the energies here, which are the potential energy, kinetic energy, and the wasted energy due to friction, because this is inclined. Okay, so there is really friction acted on it, and it's given in the problem. Okay, so this is understood to be a rough surface. The movement of the cyclist, or the motion of the cyclist, is not continuous because of the friction. Okay, so we have 500 meter Okay, this one. And then the friction force acted on the road is 60 Newton. So it's gonna be like this. Friction force. Okay, friction force. So this is 60 Newton. Okay. Question required. Okay. What is the velocity final? So we need to find the velocity final. So this is 500 meter from here to here. Okay, like that. So we need to use the conservation of energy involving mechanical energies. Mechanical energies because this is movement siya. Okay, so we use mechanical energy at point 1 or ns shell, okay, is equals to the mechanical energy at the final, this one. Mechanical energy initial, okay, is equals to the, okay, mechanical energy final. Okay, so that is mechanical energy initial will be kinetic energy at the initial plus the potential energy at the initial plus the fraction energy at the initial is equal to the kinetic energy final plus potential energy final plus the fraction energy final. So this is gonna be like this. All energy is acting on it in the initial stage or in the final stage, from the starting point to the destination point where this cyclist will go to stop, something like that. Okay, so in here originally, okay, this cyclist is not yet moving. Okay, if the cyclist is not yet moving from the top of the cliff, so there's no velocity yet. Okay, so velocity will be 0, so we will cancel this kinetic energy. Okay, from kinetic energy 1/2 mass times velocity squared, so there's no velocity yet. Velocity is 0 at the initial starting point of the cyclist above the cliff, so we need to cancel the kinetic energy. Okay, then we need also to cancel the fractional energy or the wasted energy through fraction, because it was not mentioned in the problem and it is not yet moving, something like that. If it is not yet moving, okay, so there will be no concern yet for the fraction. At the same time, it is not mentioned in the problem, so we need to cancel this one. Okay, like this. Cancel potential energy and the fractional energy or wasted energy due to fraction. And then the final destination F, mechanical energy F. So we have kinetic energy final. Yes, because that is the one we are trying to look for. Okay, like that. But we don't have potential energy. Okay, because it is now down below and there's no height. Okay, when you reach here, with the cyclist to reach at this ground surface, there will be no height anymore. Okay, our height is still unknown. Okay, but there will be no more height when the cyclist is going the ground, so height is equal to 0, so our potential energy will be cancelled. Okay, so do we have fractional energy or wasted energy due to friction? So we have, because we have fractional force that is given, which is 60 Newton here. So what remain are these quantities. Then we need to investigate one by one. Okay, like this. So potential energy is equals to mass times the gravity times the height is equals to kinetic energy final 1/2 mv squared plus fractional energy, which is 60 Newton. Okay, since this is energy or work done, so in units of fraction, then 60 Newton, which is the force, okay, times the distance. Okay, so this frictional force, okay, this is equal to the energy, okay, energy or work equal to force times distance, because we are treated here all our energies. The formula of energies are or work is equals to force times distance. So 60 Newton times this 500 millimeter, which is opposing to the motion of the cyclist in going down from the cliff. Okay, so 60 Newton times 500 meter. Okay, so 500 meter. Okay, so let's substitute values na. Okay, so mass is equals to 90 kilogram. Okay, 9.81 gravity meter per second squared. Height is unknown. Okay, and we have the 1/2. The mass is 60. 90 kilogram. We don't have velocity yet. And 60 times, wait, I have to get a calculator. Okay, so 9.81 times 90 is equals to 882.9. 882.9 H. Okay, so 1/2 90 divided by 2, 45 velocity squared plus 60 times 500, so 30,000. 30,000. So it's gonna be like this, our solution. So we substitute values like this, huh? Okay, like that. Perform the basic mathematical operations by substituting values na ta. Okay? So, how can we compute our height here? So, we need to use the Pythagoras theorem because the cliff has an angle of 5 degrees. 5 degrees and there is an H. So, by Pythagoras theorem, this is, since this is horizontal axis and this is the height, so we need to use the sine theta. So sine theta is equals to H over hypotenuse, which is the distance covered from the cyclist in going down. So sine theta, okay, like this. So sine theta is equals to H over the hypotenuse, which is the distance covered, which is 500 meter. This one. It's by Pythagoras theorem by right triangle. Okay. In that situation, we obtain a right triangle because the cliff is inclined. and from the bottom of from the ground we have an angle of 5 degrees. So we need to solve for h now. Okay, so for this, so arc tangent sine, okay, arc tangent sine of let's 500, okay, and then sine of angle which is 5 degrees, like this. H equals to 500 sine 500 degrees. Solve for the value of h. So 5 sine equals to times 500, sine 5 times 500. So we have 43.6 our height. So we have a height of 4.3.6 by using the right triangle Pythagorean theorem in obtaining the height here, from here, because this is an inclined surface. So in inclined surface, dealing with energies and work problems, if there is an angle, use the right triangle by Pythagorean theorem, okay, like that. So we have now the h, and then substitute this for the here. Okay, here there's an h here, right? So substitute the h here. Okay, so that is 45. So 45 v squared plus 30,000. Okay, 882.9 times 43.6. So 45 v squared is equals to, okay, 882.9 times 43.6 is equals to 38,494.44 minus 30,000. Okay, so 8494.44, then v squared is equals to this one, 45, 8494.44, like this. Okay, this is the solution. Okay, this is taken from here. Okay, substituting values already, we solve for the height, like that. So our velocity will be the square root of this value. Okay, so 8494.44 divided by 45 is equals to 188.765. Square root velocity is equals to 13.8 meter per second. So we have a velocity of 13.8 meter per second, which is positive. Okay, so take note guys, this is a positive velocity, but the cyclist is going down from the inclined cliff going to the ground surface. So velocity is a vector, magnitude and direction. So going down, so it must take the sign of negative. So negative 13.8. So negative 13.8 means only that it is going downward through the ground. So meaning it is having this kind of velocity. Okay, like that. Okay, because there's a fraction, meaning decelerating, something like that. Okay, the sign here is meaning going downward only, directed downward, so the velocity is negative. But if the problem here, class, is What is the speed of the cyclist at the bottom of the inclined road at the ground surface? So that will be positive only 13.8 meter per second, which is letter D. Okay. The answer is letter D, 13.8 meter per second. So we're referring here the speed of the cyclist, not the velocity. Actually, the problem is wrong. No, the required being asked is wrong because it's asking the velocity, and the velocity is magnitude plus direction. So it should be negative 13.8 meter per second. Supposedly, the negative sign will indicate only that it has a reducing velocity when the cyclist is going from the inclined cliff to the road with an angle of inclination of 5 degrees. Okay? But in this situation, guys, there's no negative sign in the choices. Then just choose 13.8 meter per second, especially if you are facing an examination. Okay? Thank you so much for watching this vlog. I hope you learned a little bit of information. If you are not subscribing yet my channel, then subscribe now if you want, and then click the notification bell of some newest updates of Emma Singer, Eternal Voice. Okay, thank you so much, guys. See you later for another problems. Okay.